Hare Krishna to all the viewers and welcome in this video where today we are going to discuss about a few more topics related to current electricity, and then we will see some numericals related to the topic. Okay. So in the previous class I have mentioned about Ohm's law, that Ohm's law equals to is V equals to IR. Okay. So I haven't mentioned about R in the previous class. So R is basically your resistance. It is denoted by this symbol. Okay. Resistance opposes the flow of current. Resistance R can be written as R equals to rho L by A. Okay. This R can be written as R equals to rho L by A, where rho is resistivity, L is the length of the conductor, and A is the area of cross section. Now let's come to this numerical. Here we have this circuit, we have this battery. This battery has a certain EMF. Okay, this battery has also a certain internal resistance, which is R, and then we have the external resistance, capital R. We have an ammeter here and a voltmeter here. We have this key. This key is basically a switch. Okay. So we have the circuit here. Let's read the question. What is given in the question? The question says, this question is from the ICSE class 10 book, Selena. So you can refer to the book, which is easily available online. So this question says, the diagram in given figure shows a cell of EMF E equals to 2 volt and internal resistance R equals to 1 ohm. So here E is 2 volt, R is 1 ohm. Okay. Connected to an external resistance of R equals to 4 ohm. This capital R is 4 ohm. The ammeter A measures the current in the circuit and the voltmeter V measures the terminal voltage across the cell. What will be the readings of the ammeter and voltmeter? Okay, so ammeter A is connected in series, voltmeter V is connected in parallel, and this is true for all the cases. You will see always ammeter is connected in series and voltmeter is connected in parallel. Now, what is the question? That what will be the reading of ammeter and voltmeter when the key is open? When the key is open, no current is flowing through the circuit. Okay, so since no current is flowing through the circuit, the ammeter reading will be 0 ampere ammeter reading. Okay, now what happens? Now what will be the voltmeter reading? So here the voltage across this path is 2 volt, so the voltmeter reading will be 2 volt. Okay, next question is, when the key is closed. When the key is closed, then what happens? Then there is this 4 ampere, then we will apply the Ohm's law. When the key is closed, we will apply the Ohm's law. Ohm's law states that V is equals to IR. Okay, so what is the total resistance of the circuit? Total resistance is 4 plus 1, 5. Okay, so R is 5, V is 2, I will be 2 by 5. 2 by 5 means 0.4. So the ammeter reading will be 0.4 ampere when the key is closed. Now what will happen when the key is closed? What will be the voltmeter reading? So since 0.4 ampere current is flowing, now then what will happen? Through this R, internal resistance, this R also 0.4 ampere current is flowing. Okay, so there will be a voltage drop of 1 into 0.4 ampere. So that will be 0.4 volt. So 0.4 volt is your voltage drop. 0.4 volt is your voltage drop. Total voltage was 2 volt. So your ultimate answer is 1.6 volt. Okay, so this is your ultimate answer. This is the question and this is the answer. When the ammeter is when the switch is open, then ammeter reading is 0, voltmeter reading is 2. When the switch is closed, ammeter reading is 0.4 and voltmeter reading is 1.6. Okay, so this is how we can solve this type of numerical. It is very easy, and if you want, you can. Let's see one more numerical for today. What is there in the second question of the day? Second question states a cell of EMF 1.8 volt and internal resistance 2 ohm is connected in series with an ammeter resistance 0.7 ampere, 0.7 ohm. Achha, this is 0.7 ohm. And a resistor of 4.5 ohm. Okay, as shown in the diagram. What will be the reading of the ammeter? Okay, so here we have 2 ohm, here we have 0.7. So 2 plus 0.7 is 2.7. 2.7 plus 4.5 is 7.2. Okay. So once again we will apply the Ohm's law. I equals to V by R. Here V equals to 1.8. Mistakes can happen, right? We are not perfect. We can do some mistakes. So look at this circuit here. Here 0.7 ohm is the resistance of the ammeter, 4.5 ohm is the external resistance, and 2 ohm is the internal resistance of the voltage, right? So total resistance is 7.2, the voltage is 1.8, so the current will be V by R, means 1.8 by 7.2, that is 0.25 ampere. Okay. Next question, what is the potential difference across the terminals of the cell? What is the potential difference across the terminals of the cell? Now this is a very interesting question. But the twist is how to calculate this. So this we will discuss in the next class, because honestly saying I am a little bit confused that how can we calculate the potential difference here. Okay, this total is 1.8, so how can we calculate the potential difference here? You can also try to solve this at home, that if this is the circuit, then what is the potential difference across its two ends, and you can also try to answer it in the comment section. Okay, actually in the book the answer is given as 1.3 volt, but how it is 1.3 volt, that I need to check. Okay, now apart from these two numericals, there are other numericals based on energy and power. Okay, energy means the commercial unit of energy is expressed in kilowatt hour. But how that unit is expressed, we will discuss in the next class. So far, we have discussed these two numericals, out of which this numerical, the last part, is doubtful. So we will discuss it again in the next class. So for now, that's it for this video. Thank you for watching. Hare Krishna. Stay safe and be happy.